going. Is it going?
Yep.
Okay. All right, so this is section 6.3, which means we're at quiz time. It's called test for parallelograms. So the other day we talked about parallelograms, correct? What's the definition of parallelogram? Kind of a big thing. Yep.
Two opposite sides parallel.
Okay, it's a quadrilateral where opposite sides are parallel, right? That's by definition. But what were some other things that were interesting about it?
Corresponding angles, right? Opposite angles are parallel.
Opposite angles are congruent.
Adjacent ones are
Consecutive adjacent are supplementary.
And opposite sides are congruent.
Opposite sides are congruent. Was there anything else?
like the
Didn't the
midpoints.
diagonals bisect each other?
Yeah, the midpoint and
All right, the diagonals bisect. Does that mean the diagonals are congruent?
No.
No, it means the diagonals bisect each other. That means they cut each other in two. Okay? All right. So, what we're going to do is we're going to do the converses of all those. All right? We're going to look at how can you prove a quadrilateral is a parallelogram. So, how can we prove a quadrilateral is a parallelogram? There are 5 ways. Okay? And the first way is by definition. It's not a theorem. Okay? The first way is if both pairs of opposite sides are parallel, the quad is a parallelogram. Okay? So if you come on, if you're looking at a 4-sided figure and the opposite sides are parallel, both pairs, it's a parallelogram. Now, what if only one pair is parallel?
no.
No, it has to be both. In fact, if one pair is parallel, it is a trapezoid. Okay, so it has to be both pairs. Do we understand that? Okay, now the next ones are all theorems. This is by definition. So you could actually put on the proof by definition. Okay, all right. So the next one is 6.9. It says both pairs of opposite sides are congruent. If both pairs of opposite sides are congruent, the quad is a parallelogram. You understand that quad is abbreviation for quadrilateral. The 4-sided figure is, so it has to be both pairs, correct? Okay, so that's the second one. You okay?
Yeah.
Okay. 3. All right. The next one says if both pairs of opposite angles are congruent, then the quadrilateral is a parallelogram. So if both pairs of opposite angles are congruent, then the quadrilateral is a parallelogram. That is not very good writing. Now it has to be both pairs of opposite sides, or opposite angles, excuse me. Not just one pair. It has to be both. You have to prove that. Okay, the 4th way is 6.11. If the diagonals of quadrilateral bisect each other. If the diagonals of a quadrilateral, I'll just put if the diagonals, just to keep in line with the rest of it. If the diagonals bisect each other, the quadrilateral is a parallelogram. Okay. Okay, the next one is not the converse. Okay, it is a free-flowing one, but it works. And it says this, if one pair, and it has to be the same pair. If one pair of opposite sides are both parallel and congruent, the quad is a parallelogram. It can't be a different set. It has to be one pair, and it has to be the same pair. You see what I'm saying, Jaws? So if I take a look at this, if this side is parallel to this side, then this side has to be congruent for this to work. Okay? Yes?
So let's say the quad is a parallelogram.
Yeah, the quad is a parallelogram. Thank you.
Quad is a quad.
The quad is a quad. There are 5 ways to prove a 4-sided figure is a parallelogram, and here they are. You understand that? Okay? Now, let's take a look at your worksheet. Take a look at your worksheet. Okay? The first says, determine whether each quadrilateral is a parallelogram and then justify your answer. So you're going to say yes or no, and then you're going to write, if it's yes, you're going to write one of these things down. If it's no, you're out of there.
Right, so the whole definition?
Yes, the whole enchilada. Okay, so let's take a look at number 1. Is that a parallelogram?
Yes.
Yes, and which one of these?
Diagonals.
All right,
Yeah.
so number 4, if the diagonals bisect each other, the quad is a parallelogram. You write that. Okay, number 4. Jump to number 4. Gigi, what do you think?
Yes.
Why?
If one pair of opposite sides are both parallel and congruent, the quad is a parallelogram.
Okay, hold on a second. You don't agree with that?
No.
Why not?
Because she said, didn't she say if one pair?
Yeah,
She said both.
okay. I think she's on the right track. Both specify that a little bit better.
Both pairs of opposite sides.
It has to be the same. It has to be the same
Oh, so
pairs. Yeah. So it's a big fat no, isn't it? And we're done, right? Okay. The 2 hardest problems.
Two.
What's that? What about 2?
Because only
Same reason.
Only what?
those two. Okay.
Oh, so what do you put? What do you think?
I got it.
Okay, you put no, right? Okay, yeah, you're right. It has to be both pairs, Kyle. It has to be both pairs of opposite sides of parallel, or it has to be that they both have to be parallel and equal, or congruent, right? Okay. All right, so down below then, number 7, 8, 9, and 10. You notice that we skipped number 5 and 6 because they are by far the hardest. Okay, so we skipped 7, 8, 9, and 10. But it says algebra, find x and y so the quadrilateral is parallel. Excuse me, it's a parallelogram. Let's take a look at number 10. All right, number 10. Now, Mr. Ellis is going to work on these with you, but you're going to have to do these on the test. Okay, so if you don't understand something, I know you guys want to get your homework done, and I understand that. I get that, but you better ask because you're going to have to know it. Take a look at that. How do we solve for x and y on number 10? We'll start with you, Addie.
2x or negative 2x plus 6 equals x plus 12.
Okay. And can I solve for x there?
Yes.
Yes, I can. I just solve for x. All right. And then how do I solve for y, Kyle?
3y plus 5.
I'm on number 10.
Y plus 23 equals 4y minus 2.
All right, negative 4y minus 2, right? Okay. All right, and you solve those like that. Okay, I'm gonna give you a few minutes to just do x, please. Just do x. And then we're gonna move on because I'm telling you, 5 and 6 need some time. Yeah. You didn't need them? Okay, we're gonna hold on, Missy. Cause I'm, nope, you're not leaving. You're not leaving.
So I just read it quickly.
Okay, I'm looking. Okay, I checked 5, right? Yep.
That's the old one.
7, good. Oh, this one. Check that one. Is that 10?
That was 10 now.
Okay, just do that, let me do that first. And it's, just to help you out a little bit, this is correct. And these two are not. Okay? Give me one more shot. You can use the points, eh? Okay, we have a test next week, it's kind of a big deal for you, okay?
Yeah.
All right, so what did we get for x? Kyle, did you get a value in x or no?
3.
3? Did you guys get 3?
I got 6.
I got negative.
I got
Negative 2.
Negative
Oh
2.
my goodness sakes. All right, let's subtract x from both sides.
Oh yeah, it's negative 3.
Negative 3x plus 6 equals 12. And then subtract 6 from both sides. I got a negative 3x equals 6.
So it's negative 2.
Alright, alright. Okay,
Oh,
yes, Freeland.
no, my hair is really light and I didn't see my negative. That's all.
Alright,
I know how to do it though.
okay. Alright, so 5 and 6, let's read
That's
those.
fine.
Okay, because this is where we struggle. This is where it's going to struggle. Okay, it says graph each quadrilateral with the given vertices. I gave you graph paper? No. All right. I gave the other 2 graph paper that were gone today, right? All right. So we're going to put this in our notebook now that we all have one.
I got graph paper.
Well, good for you. Oh, you got the good stuff too. Where'd you get that? You just need
I
one.
got it like the beginning of the school.
Is that mine or you? That's,
That's mine.
yeah, I was gonna say, I don't, school can't afford that stuff.
It's graph paper.
The
Yeah.
school
Like
can't
really
even
nice
afford.
graph paper.
It's like dark graph paper, it's like that,
School can't even
I got
afford
your
the
own graph paper.
It's like the laminated graph paper.
They didn't have like a press it.
But you notice that it's light too,
Yeah.
and that's good, so you can see your writing on it. Yours might be a little hard to see your writing on, you gotta press real hard.
No.
Oh, okay. Alright. Kinda personal about that, aren't you?
No.
Alright, so let's talk about 5 and 6. I'm gonna talk about 6 because it uses both of them, okay? It says, graph each quadrilateral with the given vertices, determine whether it is a parallelogram, justify your answer with the method indicated, okay? Take a look at number 6. I got it up here on the board, okay? I got it up here on the board. It says, use the distance and slope formulas, okay? Distance is going to tell us that the sides are equal. You understand that? I'm going to say it again because I don't think you're listening. Distance is going to tell us that the sides, opposite sides are equal. Okay? Slope is going to tell us that opposite sides have the same slope. If they have the same slope, then they are
Equal.
parallel. Okay? Now, 5, we have to do both pairs of opposite sides and make sure both pairs of opposite sides are equal.
5 or 6.
I'm talking about 5 now. I'm trying to get you to look at 5 too. 5, you do opposite. All you have to do is the distance formula, and all you have to do is make sure that both opposite sides are the same.
You just do slope
It's
formula.
just yeah.
Oh, is it just slope on 5?
That's what you're
Well,
confusing.
I'm lying. I'm a big liar, big fat liar. Well, I'm fat, but I'm not that big. Okay, so I'm a liar. So it's just the slopes.
So
All right.
formula
So
is just for 5.
yes. Okay. Do you know how to find slope?
Is it y?
Y by people or
Y
Y.
equals mx.
No. When you're given coordinates,
You have to, isn't it,
take the
y?
changing y over changing x. Okay, so on number 5, you have to do the slope of these two sides, and you have to do the slope of these two sides, whichever, you'll have a different rectangle, you'll have a different quadrat, and you have to show that the slopes are equal. On our problem that we're doing, we're just gonna take one of the sides, one pair of sides, and show that not only are the lengths the same, but the slopes are the same. And we're gonna use this concept. 5, we're using, is it slopes? This, by definition. 6, we're using this. Do we understand that? Okay, so let's do 6 because we're gonna use both of them. So, which sides do you wanna pick? Do you wanna pick this side and this side, or this side and this side?
R and Y and O and M.
Okay, you wanna pick the longer side.
I don't know.
Okay, alright, so we're gonna pick RM, this is number 6, RM, we're gonna find the distance, and the other one was
O, or,
OM,
it's
right?
O, M and R, Y.
Oh, I didn't get that right. RY and OM. We good? Alright, now, we're going to find distance and slope. The distance formula is the square root of x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. Do you remember that?
Yes.
Okay. Alright, so we have to take RY. What is, give me R. What's the coordinates for R?
Negative 2, 5.
Negative 2, 5, and what's Y?
Negative 6, negative 2.
Alright, okay, so let's find the distance, alright? So I'm gonna take the square root of x sub 2, it doesn't matter, so I'm gonna take a negative 6 minus negative 2, quantity squared, plus, and I'm gonna take the y. If I took the negative 6 first, then I have to take the negative 2 minus a negative 2 squared. We good? So now I get the square root, this is plus a positive, so I have a negative 4 quantity squared, plus,
Yeah, no, wouldn't it be, no, you're right, yes, sir.
minus negative 2, I did plus a positive, that'd be minus 4 quantity squared, plus, and this is plus a positive, so that'd be 0 squared, correct? Alright, when you square a negative 4, you get a positive 16, and then we just have that, right? Now, if it doesn't come out, say this was 17, leave it as 17. Are you done? Okay, did you leave it on my desk? Okay, just leave it on my desk. We'll,
I think I got.
okay, well, if you did, you did. Yes, ma'am.
The why is it negative 2 or minus a negative 2?
Did I mess up? A negative 2, oh, I did
Yeah,
mess up.
you did.
What should it be?
5.
Minus 5, right? Thank you.
Thank you.
Yep, and then a negative 2 plus a negative 5, I'm getting a negative 7 squared. Is that correct?
Yeah.
All right, good. I didn't want it to come out even. So I get 16 plus 49, which is what? 15 square root of 65? Is that right?
Yes.
Yep.
Okay, now let's do the other one. What's O?
O is.
Negative
It's
1,
1,
3.
3. It's just 1, 3.
1, 3,
Oh, shoot, no, negative.
and then M?
Negative 3, negative 4.
Okay, so distance
Hold up.
equals, now notice, if you keep this nice and neat, you don't get confused. Now, if we don't get the square root of 65, are we done?
No. Yeah.
Yeah, we're done. They're not. It's not a parallelogram. I'm assuming we're gonna get the square root of 65, because we have to prove it, right? So we're gonna take, change in x, so we're gonna take 1 minus a negative 3 squared plus, let's see if I can do this right, 3 minus a negative 4 for quantity squared. Is that true?
Yes.
So do you not have to like keep it the same? So like when you did it for R and Y.
No. I can go either way as long as, and I did that on purpose, Addie. So this one, I took this one minus this one I'm taking this one minus it. It doesn't matter as long as you go from the same one, okay? So I'm gonna do plus a positive, so I have 4 squared plus a positive 7 squared. So I'm getting the square root of 16 plus 49. Does that look familiar?
It does.
All right, we both got the square root of 65. So they're both the same, right? Okay, But the rule says is I gotta have both sides parallel and congruent. I just proved that they were congruent. I haven't proved that they were parallel. So parallel is slope, which is little m, remember? Little m, and it's change in y over change in x. So it's x, or it's y sub 2 minus y sub 1 over x sub 2 minus x sub 1, okay? This is a formula you should know from Algebra 1. Change in y over change in. You might not know the formula, but you know how to do it. So we take the y's and we subtract each other. So we have 5 minus a negative 2. Hair on the board, I can't get it off. It ain't from me. All right, and then I got a negative 2 minus a negative 6. Make sure you get that correct. It's y over x. Is everybody good? Greeley, what's wrong?
No, I'm just really confused.
Okay, really.
I got it.
All right. So this is 7 over what? 4. So we better get 7 over 4 here, right? All right, let's try it. Change in y. So I'm going to change it now. I'm going to go 3 minus a negative 4. When I do it, I still do the y's. I'm just doing different order pairs. Over 1 minus a negative 3. So I'm getting 7 over 4. The slopes are the same. So therefore, this is a parallelogram. So I write this. If one pair of opposite sides of a quadrilateral, I didn't put up a quadrilateral there. If one pair of opposite sides are both congruent and parallel, the quadrilateral is a parallelogram. Now in 5, you don't use this method, do you? You just do both pairs of sides and you do slope, right? Okay.
So you can skip a step pretty much.
No, you actually end up, and I don't know what it looks like, but just using this picture, and I hope you can see this picture on the video, but you would find out what the slope of this was and this was using your 2 ordered pairs, right? And then you would check those slopes. If they're not the same, you're done, right? Okay. Now, and then you do this one and this one. So it's still,
You don't have to do the distance for me.
no, not the distance. And it's much easier, I think, to do slope than distance. But that's my opinion. Okay. All right. Do we have any questions? Cross out number 11. We're not doing number 11. So we're 1 through 10. 1 through 10. Okay? And we have a quiz tomorrow. Okay? Or Thursday.
Tomorrow
So
for some people.
tomorrow for some people.
I was just gonna take it like Thursday.
Okay. I might, if you guys remind me, I'll review in class tomorrow. All right? If not,
Do you want us to graph number 5 and 6?
yes, please. That's,
Do we need to use a straight edge?
no, you can sketch. Okay. Did you shut it down?